Bonjour people, my name is JEE and I welcome you to this episode of La JEE Mains Adv. This series aims at revising the topics that are generally overlooked by aspirants during their preparation. Before beginning, let us revise a prerequisite topic, that is conformational isomers. Now this is the kind of isomerism that is shown due to the rotation about a single bond. Now a single bond is like a piece of thread. Anything and everything can be rotated about it. Similarly, a single bond, the groups about a single bond can be rotated easily. Now this is a temporary configuration in molecules. These change at all times with the fluctuations in pH, temperature, etc. It can be anything, many factors. These cannot be separated because these are temporary configurations. Let us look at an example. Suppose I draw the Newman projection of one molecule. This is one way of drawing the molecule. But if I change the configuration, suppose if I rotate the back part of the molecule, it can be shown as this. Now this can also be shown in another configuration in such a manner. You see, these configurations, these change all the time. So these cannot be separated at any time. Let us now talk about the main topic over here, that is atropiomerism. Now these are basically conformational isomers that are stable and isolable compounds, and thus they are known as atropiosomers pertaining to atropiomerism. Quite a mouthful name. Now this isomerism can be seen in situations like this cute little benzene system over here. Now there are some really bulky groups about the single bond between the two phenyl rings. That is group A, group B, group C, group D. These are so sterically hindered that rotation about the single bond is virtually impossible. So we can say that there are rotational barriers between the conformers, and therefore they can be separated easily. Since they can exist as separate conformers, they can be easily separated. And sometimes these conformers can also be stereoisomers. Well, that depends on the situation, so to speak. Let us take the example of binap. Now binap is a really sterically hindered compound with a single bond between two naphthalene rings. The left hand side is the S binap and the right hand side is the R binap. These are reversed compounds, you can say. The S binap, as you can see, the phosphorus with a naphthalene ring and two phenyl rings becomes really sterically hindered with a lone pair on the top of it in the green which I have shown. And thus it becomes virtually impossible to show any rotation about the single bond. You need to apply a lot of heat, lot of pressure and lot of temperature to break these bonds and make the rotation possible. But in that the compound may be decomposed. There may be some other changes that you can see. And the similar is the case with R binap. So these two compounds are virtually different, like the optical isomers that we know of. So folks, with this we come to an end to the episode 2, Atropiomerism. Stay tuned for more, and remember, be limitless because you are limitless. All the best to all of you.